Ever wondered how natural gas gets from the well to your home? There's a lot that happens between the time a well is drilled and the time gas heats your home or cooks your food. The journey is just beginning when the gas surfaces. The next stops for gas: pipeline, processing, and compression. Most of us don't realize gas straight from the well is very often unusable for commercial purposes. It's mixed with oil and water, which need to be removed through several processes. And gas needs to be brought to the proper pressure for transport. Compression and processing equipment are easy to spot, but the pipeline bringing gas to compressors and processors and eventually to your home is almost always underground, invisible except for markers showing where the pipe is buried. If you're wondering how all this equipment works in concert to make gas a usable and efficient source of clean-burning energy, well, I'm glad you're curious, because we've assembled a team of industry experts today to give you an inside look at all the machinery and parts in the field that bring natural gas to a transportable state. We'll see the pipe that carries the gas throughout the route from the wellhead to where it's sold. Now, this is called the gathering phase of the journey. We'll see how gas is processed or separated from oil and water so it's usable, and we'll visit many kinds of compressors giving gas the boost it needs to travel through the pipeline system safely and efficiently. Straight from the wellhead, gas sometimes can flow directly to a main transmission line, which then takes it to a sales meter where utilities purchase it. But gas often needs processing and additional pressure at the wellhead. In fact, there can be so much water mixed with the gas that water actually prevents gas from flowing. It literally weighs it down. Now that's when you call in a gas lift.
This is how a gas lift works on this location. Compressed gas is diverted back to the well through this valve right here. From here, the gas is pumped down the casing, forcing the fluid, which is weighing down the gas, up the tubing. This allows the gas to flow more freely.
The water ends up in deposit tanks, like these, and the gas flows into the pipeline. Gas travels in an above-ground steel flow line from the wellhead to what's called a production pack or production unit, also at the wellhead location. This unit separates out a good bit of the oil and water present in all raw natural gas. It's usually used in high-pressure flowing wells. The production pack helps control the flow of gas coming from the wellhead.
After the fluid leaves the production pack, it can be sent to a heater treater like this one. At that time, the heater treater uses heat to further separate the oil and the water and send it to the appropriate tanks.
Excess natural gas that powers the heater treater and pushes fluids through the system is recovered and sent to a small compressor called a flash gas compressor. Gas compressed by this unit typically travels a sales pipeline directly to the utility sales meter. For still more processing, you'll sometimes see separators at the wellhead site too. Low-pressure compressors often are used as a final step at the wellhead to bring gas to the proper pressure for the next part of its journey, the pipeline. Before the gas enters the line, a sales meter records how much the well is producing. The pipeline brings gas to a location where it'll be processed and compressed again, depending on its condition and what the utilities buying the gas require. Pipelines from the well to the next processing facility can cross miles and miles of land that's treated with the highest respect for its existing condition. Once the pipe is safely installed underground, the area will be restored to its former state. When the pipeline's path is cleared, miles of steel pipe are positioned. We call this stringing the pipe. Different pipe is used in different situations during this gathering stage of transport, when natural gas is transported from the well to a central processing or delivery facility. This 16-inch diameter steel pipe is often used in pipelines. The green color is actually protective coating. Around here, pipeline can be as narrow as 4 inches in diameter all the way up to 48 inches, depending on volume and pressure. The higher the pressure, the more gas you can move through a smaller diameter pipe. You can also find polypipe throughout the gathering system, used in lower pressure applications. The strung pipe is resting on skids, wooden platforms which protect and stabilize it until it's placed in a trench.
Part of it could be soil conditions. as far as what we want it, but 48 inches is basically a standard. Landowner could want it at 50, 60 inches deep cover, and in urban areas it's going to have to be deeper because of existing pipelines or telephone lines, anything like that that's underground is going to have to be deeper.
Before the pipe is buried, it's leveled with precision accuracy and fused with 3 super strong welds at each joint.
They're lining the pipe up right now. Then they'll be using a inside line-up device, which is like a balloon. It'll compress and go out against the outside of the pipe. It'll keep it in alignment. And then they'll run 3 passes with the welder on it. And that's what the guys are doing. It's coming back behind. They'll run their 3 passes and continue down the line.
X-rays, taken on site with a special mobile unit, determine if there's even the slightest flaw in the welded joint that could lead to weakness.
First off, we cone off the area for our 2 MR boundary to keep people out of the area that we're testing in. And then we strap the pipe, the welds, with cassettes, and we take 3 views. We use iridium 192 for its radiation to take a picture of the weld, then we process it, and then we view the film for any defects.
Any potential problem areas are revealed, removed, re-welded, and re-X-rayed. The joints are determined sound, and the pipe is wrapped with pipe joint coating to protect the joint underground. Soil conditions might require a rock crusher to pulverize larger rocks in the trench before backfilling, so there's less risk of damage to the pipe's coating over time. A rock shield can be wrapped around pipes to further protect them if necessary. Safety is key when installing a pipeline. When a trench is ready, the pipe goes in.
After it's welded and they've got the trench, they'll bring 3 side booms in and use a process called cribbing, and they'll lay the pipe into the trench. The pipe will have enough flex that it will not allow any damage to the welds or to the structure of the pipe.
There's one more important safety test before gas flows through the line. The underground pipe is filled with water that reaches a pressure 1.5 times greater than the highest pressure pipe gas will ever reach. Any possible leaks will be detected during this hydrostatic testing and then repaired. In some cases, the pipeline needs to travel around or under an obstacle that can't be disturbed, like a stream, a rock formation, a road, even landscaping. So pipe can navigate these areas a couple of ways. Now, one way is through a process called directional boring, which brings the pipe under the area.
We dig the hole on one side or the other, put the boring machine down in the hole, and we will drill a 2-inch hole under the road, and it will be attached to a cable on the other side with a boring tool that will bore the hole out 4 inches bigger than the pipe diameter we are using. And then that allows your pipe to be positioned wherever you want it under the road.
This kind of engineered directional drilling is actually a lot like the technique used in horizontal exploration for gas. Another way to get pipe flexibility is by bending it. Now, this procedure is overseen by skilled engineers who can create an actual bend in the pipe without stressing the pipe or its joints.
Bending is necessary to go around obstacles, or to come in straight across the road, or to come in to a certain point in a location to where they want to hook up the well or meter run, to go around land in particular, or a barn or whatever he may have, just to reach a point A to point B.
On its way to the central delivery point, gas may travel the pipeline to a header station. That's where gas from many wells meets and flows through one main pipe called inlet piping, which carries it into the CDP. A lot has happened to the gas since it left the well, but there's so much more activity here at the central delivery point. The CDP is where a lot of equipment helps gas reach the proper pressure and quality to be sold. From the inlet piping bringing gas into the CDP, gas passes through an inlet separator. It does an initial knockout of water and oil. Some fluids have accumulated in the pipelines, and some have been released by gas as pressure and temperature increase.
At the inlet of the CDP, these separators will remove that fluid using internal screens and baffles and send it to the appropriate tanks.
Gas then goes on to a header, a lot like the one you saw in the field. But this time, the header is bringing gas from many sources to a compressor or a group of compressors. The compressors at a CDP are often much larger than the compressors at the wellhead, and there are more of them. The more gas entering the CDP, the more compressors are needed on site. So, if many wells are feeding a high volume of gas to a CDP, you'll see several compressors at that location. This CDP has 4 3-stage compressors. In this location, they're boosting the pressure from 65 pounds per inch to 1,000 pounds. To increase the pressure that much, gas is compressed gradually in 3 stages to prevent the gas from overheating. One way you can tell that the gas pressure has been boosted is the exit pipe. Notice it's much smaller than the pipe carrying gas to the compressor. That's because the gas has been compressed so much. Often walls surround much of the compressor to reduce noise and provide protection. By the way, compressors' coolers often face south, so they can take maximum advantage of prevailing winds.
This is a 1,380 horsepower gas compressor. This particular unit's 2 stages of compression. They come in single, 2, and 3 stage, and even 4 stages of compression.
Compressors are complex machines that take about 3 to 4 weeks to build. The higher the volume of gas, the higher horsepower needed in a compressor. The greater the pressure difference between incoming and outgoing gas, the more stages needed.
After it leaves the first stage, it is superheated and has to go to a cooling process. After we cool the gas, it goes to a scrubber to drop out any entrained liquids before the next stage of compression. And then if it was a 3-stage, it would go through a cooler and then a scrubber and then another cooler and then a sales line.
These 60 to 70 ton 3-stage units are delivered partially assembled to the CDP site. If the compressor is coming to a brand new CDP, it takes about 2 to 6 weeks to get the whole operation up and running. If it's an existing site, the compressor can be doing its job in as little as 2 days. Before we finish the compression process, let's look at some other compressors that you'll see in the field. Gas jack compressors are a lot smaller than the big 3-stage units.
These compressors use an automotive-style engine powered by natural gas. These units are normally more efficient than the larger horsepower units at lower volumes.
A slow-speed compressor is a low-speed unit that boosts gas pressure from the wellhead to the CDP, or in the pipeline leading directly to the sales line.
These compressors can be used in both low and high pressure applications. They're a reciprocating type compressor which can have 1 or more cylinders. They can easily be identified by the large muffler and flywheel.
Rotary screw compressors are used in low pressure situations. They can take gas from a vacuum to 250 pounds of pressure without overheating the gas.
The rotary screw compressor has an oil and gas separator located on the skid. What you can't see is internally there are rotors which compress the gas as opposed to pistons on a reciprocating compressor.
You saw the flash gas compressor in action at the wellhead location. Actually, flash gas isn't a type of compressor. The name describes how the unit is used.
This 3-stage reciprocating gas compressor is being used in a flash gas application. If you will remember, flash gas is the excess gas from the heater treater that is being used to separate the oil and water.
Small electric drive compressors can pull gas vapors off water and oil storage tanks to make sure that every last bit of natural gas is being used.
This electric drive natural gas compressor uses no natural gas for power. However, it does require a steady source of electricity. The recovered gas from this compressor either goes to the sales meter or back to a flash gas compressor.
Now let's get back to our CDP. From the compressor, gas flows to the dehydrator. That's where it's processed again to remove water. The dehydrator's secret ingredient? It's heated glycol.
Gas comes into contact with the glycol at the contactor tire. Glycol is an agent that bonds with water. At this point, the glycol is sent to the reboiler, where it is heated to approximately 370 degrees. At that temperature, the glycol will release its water in the form of steam, which is sent to a storage tank. The glycol then returns to the contactor tire where it resumes the process. The results are cleaner, drier gas.
At the CDP, you might notice some other equipment we haven't talked about. Now, these tanks alongside the compressor store oil, antifreeze, and other products used for maintenance. This device, it's called a pig, and pigs come in many shapes and sizes. Believe it or not, something called a pig is used to keep pipe clean. Pigs ensure the CDP pipe system is operating at peak efficiency by actually entering the pipe and removing liquid debris. So, just like a snake cleans out the pipes in your bathroom sink, a pig cleans out the pipes at the CDP.
This is a pig launcher. We evacuate the pressure out of the pig launcher, remove this cap, install the pig, replace the cap, and as we introduce the pressure back into the pig launcher, the pig is forced through the pipeline and forcing the fluid out the other end. The fluid is captured and sent to a storage tank.
Processed and compressed gas then travels a transmission line from the CDP to the sales point, which is often right on site at the CDP. A sales meter like this monitors the pressure and the amount of gas flowing into each utility's pipeline system. The gas then continues on to the processing plant and eventually to your house or an industry. The pipeline's distance potential is limitless. In the U.S., there are lines stretching from the Gulf of Mexico to Maine. As the gas begins moving through the pipeline, restoration of the reclaimed land has already begun, bringing it back to its former state. Regular maintenance ensures the pipeline can last a lifetime. So now you know. Pipelines, processing, and compression. They're working together to bring clean-burning natural gas to folks who depend on it. Folks like you and me. We'll see you next time.